Okay, today we're going to do notes 11. It's slope as a rate of change from equations, patterns, and pictures. So we're just basically trying to find the slope of different things. And we kind of did that yesterday when we were doing our slope activity around the room. So when we're looking at it from equations, the slope is a constant rate of change, and it is always the coefficient of the input x. Okay? So, if I'm looking at problem number 1, it reads, Miss Jenkins used 30 pounds of hamburger meat to make sloppy joes for the football team dinner. She scooped the same amount for each sandwich. Each scoop was equal to 1.5 pounds. The linear model is represented with the function h of s equals 30 minus 1/2 s. Okay? It gives you a table over here. Okay? So the question is, what is the rate at which Miss Jenkins scooped out the sloppy joes? So what's my rate of change? What's my slope? Somebody said it.
Oh, yeah, negative 1/2.
Negative 1/2. Okay, I know why you would think it was 30 because you're used to it being in y equals mx plus b form, right? Okay, but think about where my x is. My variable is here. So I'm looking really at the number, the coefficient right before. So it's not just 1/2, it's negative 1/2. What is the 30 in this relationship? Is it the number of scoops, the total number of players, the starting amount of hamburger, or the amount of hamburger left after S scoops? The starting amount. It's like our y-intercept. And then how many sandwiches could be made from 30 pounds of sloppy joes? So, yeah, it would be 60. That's an easy one. So a couple of things that you could do is if you wanted to find out how many sandwiches could be made, set it equal to 0 because I want 0 pounds left, and then solve for S. So I would subtract 30. I'm going to actually do, I would move 30 to the other side, and it equals negative 1/2 S. And then I could divide by negative 1/2 or multiply by negative 2. That's what I'm going to do. To get S, the number of scoops is 60. Okay. That's how you do it mathematically. You just set your equation equal to 0 and solve for your variable. Okay. With this one, it's kind of easy because you've got 30 pounds. Each one is 1/2 pound. How many can you get? Any questions over problem number 1? Okay, let's look at problem number 2. When we're given a pattern, okay? So, like the one to the right, we find to the nth term. Okay, so let's talk about this, okay? Which of the following expressions could be used to find the perimeter of the nth set? We've got A equals n plus 4, B equals 4n plus 2, C equals 6n, and D equals 8n minus 6, okay? But we don't have anything to compare it to. We got nothing. We just have this, okay? So what we do is this set 1 is like our first x. Set 2 is like our second x. Set 3 is like our third x. Okay? And it wants to know the perimeter. So how do I find the perimeter? I add all the sides. Okay? It's not asking how many boxes I have. It's asking what my perimeter is. So when we're looking at boxes like this, our perimeter is counted 1, 2, 3, 4, 5, 6. Set 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Because it's asking for perimeter, it wants all of our sides added together. Okay. If it was asking for like the boxes, then that would be a completely different problem. You just count the number of boxes. Okay. So then what I do is I use my answer choices, okay, and I'm figuring out what my equation would be. Well, if I put 1 in for my n, this is like my n, okay? If I put 1 in for my n, I have 1 plus 4, does that equal 5? Does that equal 6?
No.
No. What about, I'm going to go down to C. What about 1 times 6, that equals 6, right?
Yeah.
What about 2 times 6, does that equal 10? No. Okay, so 4 times 1 is 4 plus 2, does that equal 6?
Yeah.
Okay, what about 4 times 2 plus 2, does that equal 10?
Yes.
3 times 4 plus 2, 14?
Yes.
Okay, so that could be it. Just want to double check, let's make sure. 8 times 1 minus 6, is that 6?
No.
No. So our answer would be B.
That wasn't.
It's not too complicated. The most complicated part is making sure you're paying attention to perimeter, or the other word they use is like boxes. Like how many boxes, I think.
No.
So for one on your assignment today, number 10, it says the number of triangles. So instead of counting the perimeter, like this 1, 2, 3, but this would be 4. And then this would be like 8 triangles. How many triangles? Yes?
When I did try to figure out what the answer, if I thought of the first 2 boxes as the wider set. Right answer.
It could have been, but it's not always going to work out, I don't think. So just be careful with that.
Right?
Yeah. Okay, problem number 3 from pictures. So pictures like ramp or right triangle, the slope is the rate of vertical change to horizontal change. Okay, so you know your rise and your run and hypotenuse. Yesterday, some of you were trying to do the Pythagorean theorem. We'll do the Pythagorean theorem like last 6 weeks of school, just as a like after your STAR test, like as a we're getting you prepared for geometry type thing. Okay. So when you're thinking of triangles in my class, think of it as rise and run, and then that's the hypotenuse. I don't really care about it right now. Okay. So you never use the scientific height. So what is the slope of the 13-foot ladder? Because that's what we're trying to find the slope of, is that 13-foot part as it leans against the building. Well, how much do I rise?
5.
And how much do I run? Can that reduce?
No.
No, so there's my answer. Seriously. What about, what's my slope here? How much do I rise? How much do I run? Does it reduce? To what? Okay. Now, one of the things is if you have a triangle backwards, like this, okay,
Is it a negative slope?
it's always positive. Because we're in the real world. Okay? Yeah, like you're always going to have a positive slope because that's what you're looking for. That's, like, even if it's backwards, even if it's supposed to be a negative slope, it's going to be a positive slope that you put down. Okay? This is the, like, one exception for not following the rules of slope. So this needs to be a positive slope. Because, like, even if I had, like, a ramp, ramp sitting here like this, like, I don't care what the negative slope is going to be. I can't go into the ground when I'm going into a negative slope. It's just a positive slope. Are there any questions over any of this?
No.